Hi there. In the last episode I demonstrated GP probe, and I trust you have seen this video. If not, follow this link. Today I will show how the entire system works. Very briefly, our system consists of 3-channel GNSS probe and software called GP Cloud. The probes measure the parameters of all visible satellites and send raw data to the cloud every second. In cloud, we use a neural network to detect and classify anomalies. The system can detect all types of GNSS spoofing and, of course, jamming. I'm in Poland right now, in Warsaw, near a busy road, and this is the best place to test our system. Check out our article about in-car jammers to learn why. I'm going to install the probe on the 6th floor on this building. I am on the 6th floor. Below we see a huge traffic, and here we see downtown. Why it's important? In some regions we observe the operation of anti-drone systems with GNSS spoofing, and we will check if it's true for Warsaw. Let's now install the probe. Our system does not require a complex antenna system. You can see I'm using cheap magnetic antennas. The distance between them is not important. Our system is calibrated to work in real urban environments. In such conditions, we reach 3 seconds of spoofing detection latency and less than 0.1% of false positive ratio. And this is the major advantage of our solution. So, one day left, let's review what we caught. But first I will introduce the user interface. Here we see a dashboard with statistics, then a map with all connected probes, and charts with data. These are the main components of the user interface that we are going to work with. Let's start with the dashboard. It's divided into 2 sections: real-time data and statistics on detected events. Here we see 35 active probes showing normal status. 1 probe went offline. The system can detect spoofing, jamming, anomaly, low position or time accuracy, PPS offset, and hardware error. All data on the user interface is updated every 10 seconds. Here we see an estimation of the quality of all connected probes. Below we see the statistics of registered events. We can find out how many incidents were detected, duration, and what constellations were affected. On the map we see all the infrastructure. The map supports 3 operating modes: real-time and historical data, and statistics. It's possible to visualize different parameters. Now we can see the status of the probes in real time, almost 100% for each device. Let's pick the number of visible satellites. In this menu we can adjust the colors for the heat map and choose a constellation. Let's pick the signal-to-noise ratio and switch to historical mode. At the bottom you see a graph of the signal-to-noise ratio for the probe installed in Warsaw. When I move the cursor, all the values on the heat map are updated. Let's select the number of visible satellites and try the same. Let's have a closer view of the probe in Warsaw. Signal quality is 93% in real time. Let's check the statistics on spoofing. And we see that there has been 1.5% spoofing in the last 24 hours and 1.85% jamming. Let's go back to history mode. One of the coolest features of the user interface is that you can zoom in and out on the graph using a mouse scroll. Let's analyze the incident in more detail. In order to access all the data, let's click on the graph icon here. We have moved on to the charts section. Here we see all the connected data sources. And here is a graph of the probability of jamming detection. Let's get a little closer. First, I will show you all the data we have here. Traceable constellations, GPS, Beidou, GLONASS and Galileo. Total quality and quality for a particular navigation system. Scrolling down and we can see the spoofing and jamming probability graphs. Based on the cursor, the system detected jamming for GPS and Galileo. GLONASS was almost unaffected. Below we see that the signal-to-noise ratio has degraded. A number of visible satellites and residuals. Here we see the signal-to-noise ratio and residuals for each satellite. For more convenient data analysis, I pinned the jamming chart on top and changed the layout. Now it's much better. You can see how the signals were degraded. Scrolling down, horizontal position accuracy, T-DOP, and there is the spectrum waterfall and the power in band. Let's choose a more compact layout. These red dots indicate that there is some extended data here. We see a spectrogram and power spectrum of a frequency-modulated jammer. We're now looking at recorded data. Let's switch to real-time mode. Here we have three ranges of real-time data: 15 minutes, 1 and 3 hours. In the last 15 minutes, spoofing and jamming charts are clear, no signal quality degradation. And another cool feature of our user interface. You can drag and drop the chart and you can create your own layout. Let's switch to 1 hour and we see one jamming episode. Let's investigate it. On the spectrum waterfall we see an interference. It's hard to say what it was. If it was a jammer, the center frequency is obviously badly tuned. We can zoom in or better zoom out. Nice, now we see a lot of interference. Let's put the spectrum waterfall between jamming and spoofing charts. Okay, nice. Let's check some spectrograms. It's a jammer with frequency modulation. What's the nice interference in GLONASS band here? Looks like a wideband noise. Only GLONASS is affected. What is it here? On the jamming chart we see that the interference affected GPS and Galileo. On the spectrogram we see just a carrier with central frequency identical to L1. It's a well-tuned GPS jammer. You can request an information from our database for any selected time range. Let's move back for some hours. Here we have some internet connection issues. And here we see GPS spoofing event. Then the second episode. Let's check the whole recorded data. So, the system detected 4 GPS spoofing events. Let's check the latest one. This is a really interesting event. Take a look here. The spoofing ends with jamming. This is either a random coincidence or some kind of spoofing scenario. Although I don't understand why jamming is activated at the end of spoofing. This is not an ordinary jamming, it's a broadband signal with a complex modulation. It's the first time I have ever seen that. Doesn't really look like a commercial Chinese jammer. By the way, I am often asked why we don't see spectrum fluctuations in the spectrum waterfall while spoofing. It's simple. In most cases, we do not see fake signal because the power level is lower than the noise level. Nevertheless, this is enough to overload the real signals. Scrolling down, and here we see degradation of signal-to-noise ratio for all constellations. Weird power profile. Let's now take a look at how we can configure the device. Here you see the probe configuration window, current probe status and channel status. In that section we can set basic probe description, then what constellation we want to track. The probe can be installed in fixed position or in a car. For fixed position we can set the reference point. Then detection algorithm. Here we can apply different optimization strategies: low latency optimization or lower false positive ratio optimization. It depends on your application. The system can detect jamming when signal to noise ratio drops or when the power rises. The system starts signal analysis as soon as a probe is activated. However, for better performance, it's automatically calibrated within 24 hours. Our probe is almost completely calibrated. In this section, we can change limits for some parameters. If the limits crossed, the system registers an event. Then we see the rules for a GP blocker operation, when it must be enabled or disabled. GP blocker is used to disconnect the GNSS antenna from the affected receiver to avoid spoofing. Then GNSS channel status. Here we see current firmware version. We can update firmware for all connected probes in minutes from the Cloud Admin panel. Let's now check what events we detected in Warsaw. Here we see the main event status, what constellation were affected, start and stop time, and duration. If I press Learn More, we will go directly to charts to investigate the event in more details. Here below we can check spectrogram and power spectrum. I hope you enjoy our system. I believe we have developed an industry-leading GNSS interference monitoring solution. It's easy to install and configure. Our user interface is awesome. The system demonstrates excellent performance in real-life conditions. And finally, the system is budget-friendly. About our experiments here in Warsaw. As I thought, we detected a lot of jamming events. That's predictable. But we also detected 4 spoofing incidents. The duration of each episode is a few minutes. It looks like the operation of an automated anti-drone system. I think we should continue our research here. Subscribe to our channel, more interesting stuff is coming.